Hello everyone, it's May 21st. Okay, it's a Friday. Let's take a look at what we have today. We got notification 4. I don't remember any of them. Alright, let's do this. Find and replace pattern. Regex. Given a list of string words and a string pattern, return a list of words that match pattern. You may return answer in any order. A word matches the pattern if there exists a permutation of letters P, so that after replacing every letter X in the pattern with PX, we get the desired word. Okay, I didn't understand. Let me do this again. If there exists a permutation of letters P, so is move them around, so that after replacing every letter X in the pattern with PX, we get the desired word. I still don't understand. I need to look in the examples. Recall that permutation of letters is bijection from letters to letters. Every letter maps to another letter, and no two letters map to the same letter. What's a bijection? What's a bijection? A function that is both one-to-one and onto. It didn't explain anything. A bijection, a one-to-one correspondence or inverter function. Elements of two sets where each element of one set is paired with exactly one element of the other set, and each element of the other set is paired with exactly one element of the first set. There are no unpaired elements, okay? There's a one-to-one injection and onto surjective mapping of set X to set Y. Okay. Okay, this is a bijective function, X to Y, where X is F1D. An injective, non-surjective function. An injective surjective function. Okay, so this one doesn't map to anything, so that's an injective function. This is a bijection. This is a non-injective surjective function. So everything on the Y maps to something on the X, but one can be mapped into more than one from the X. This is a non-injective because injective is everything on X must be mapped to everything on Y, and this one doesn't map. So it's a non-injective and non-surjective. Also not a bijective because this one doesn't map back. Oh, okay. Okay. So it's a injection, it's injective and surjective, right? It's injective and surjective, which just means one by one mapping. Okay, that's fine. Okay, permutation of letters is a bijection from letters to letters. Every letter maps to another, and no two letters map to the same letter. Okay, I don't understand what this permutation means. Okay, example. Me matches the pattern because there's a permutation. Okay, oh, there's a pattern. Pattern is ABB, A to M, and B to E. AQQ as well. Oh, that's the pattern. CCC does not match the pattern because A to C, B to C is not a permutation, since A and B can be matched to the same letter. Okay, this will be matching everything. All right, let's do it again. So a word matches a pattern if there exists a permutation of letters P such that, I don't like the word permutation, basically just map. It's a map of letters P such that after replacing a permutation, that's the mapping. The P is a mapping such that after replacing every letter X in the pattern with px, so like A will map into something, B map to something, and we get the desired word. So this AQQ will be A just mapped to A, but after A maps to A, B cannot map to A anymore, so B has to map to Q. Okay? Okay. I want to have 20. Word length is 50. Wow, it's pretty small. That means we can do anything we want. All right. I mean, we can just start mapping. All right? You only have 50. All right? You only have 50 for each letter. We just map. Right? So basically, the mapping is A if mapped to A. So we just check A map to A, and then B map to B. We can check. And for the third one, B, it's already in it and should be mapped to B, but now it's C, so it cannot map. So that's one is now good. Yeah, that's it. I think we just, it's depending on the size, right? The size is small, so we can just do letter by letter mapping for each word. And yeah, I don't see any other. Any other? Do we have another solution for this? Well, I mean, you can try to find a pattern, right? You can try to find a pattern. The pattern, but you need to describe, right? If you want to describe the pattern, like we have one letter followed by two letters that is repetitive. Maybe. I mean, we can use like a group. I think Python has a group to group the same things together. So you can say we have a letter and like one letter and then two letters that must be different. And but that could be like very complicated, right? The pattern could be very complicated. And given that it's only 50, right? So the maximum, so each one will go 50 times, and we have 20. So 20 times 50. Maximum is 1,000. Yeah, let's just do the easy way. Let's solve this first, and think about. Probably won't think about. Just go for the answer to see what are the better solution to this. But you have to handle the pattern. Like, how do you handle the pattern without doing it bit like letter by letter? I want to handle the pattern not letter by letter. Like, you can describe the pattern first. Can you like reject this? I mean, this is, you're not matching the exact word. You're matching the pattern, right? You're matching to say you have a letter, and then another letter, another letter. Maybe. We think about that. Let's try the easy route, right? Let's try the easy route. Let's just say we're gonna do for. I want to do it like in more interesting. So def, we're gonna say is match, right? So we're gonna say one word str pattern str, right? So this is gonna give us a Boolean value. So what we're gonna do is go word by word. So we're gonna say p, like calling to it. P is a mapping, and we say for if len word is equal to len pattern. Right? If they're not, then we're gonna just return false. Otherwise, return false. All right, and then we're gonna say for w. Oh, we have p here, so I just call it mapping. All right, for wp, we're gonna zip it, word and pattern. Right, and we say if p is not in mapping, right? Then we say mapping p equals w. We map p to w, all right? And that's fine. Else, if p is already in, and we say elif elif W is not equal to mapping P, right? That means this pattern doesn't match. Then we're going to return false. And then we go through everything, and everything good, we're going to return true, right? So here, we're just going to return word for word in words if self dot have to get self. Oh, what are you doing, man? Thought I got it. So find this a self. Right, so we go back to line 18 here. So self dot is match word and pattern. Right, so that's that. I run. We have two test cases here. Pretty long test case. So go back here. That's the first one, and the pattern is ABB. Return value is MEE and AQQ, right? So that's the first test case. Second test case will be A, B, C, D. Pattern is A, and return is it's only ABC, but it's fine. A, B, C, D is the same thing. All right, so that's the two test cases, and we're gonna handle all the parentheses, not parentheses, I'm taking about. This is the quotation marks, right, and this, okay. Here, so that's not going to be S, this is going to be words and pattern. And this is going to be find, blah, 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 words and pattern. Check it. Oh, I thought we handled this case already. How? Hold on. A maps into C, right? Oh, B maps to C as well. So B cannot map to C. Ay. Lowercase English letters. We need lowercase English letters. Like every time we map one, we have to take it out. Yeah, this just prevents from one pattern matching to different. This is preventing injection, but we did not prevent surjection. So we need to prevent surjection as well. Now to prevent surjection, we just need to have a letters. Letters going to be there easier way to do this? I think it's char 97, right? Yeah, not 100% sure, so we're gonna just double check. So I think it's a CHR 97 for not 97 for I. It's I for I in range 97 to 128, 123. 123. Probably let's do this. A B C D E F G J K T Q V W X Y Z. Yes, that's the thing. Oh, I have to do this every single time because we remove things from it. Yeah, so it's not going to be here. Mapping and letters for I in range 97 to 123. So these are the letters, right? So WP in it. So we want to map P to W, right? And if P is not in mapping, so two things, right? So we need to see we want to know if P if P has not been, if P has been mapped before, then we check if the current letter maps to it, right? That's true. If P has not been mapped before, then we need to know if it's possible to map P to W, right? So we're going to check again if it's possible, which means if W is in letters, right? Then we know it's possible, so we map it to it, and letters dot remove W. Else, we return false, right? So this is P not seen before, and W not mapped before. P not seen and W not mapped. Right? So this one is bless you. P not seen, but W already mapped. This is failing surjection. Right? The failing surjection. And this one is P not seen. No, P seen, but not mapped to W. This is failing injection, right? So with this change, we pass. All right, let's take a look. Here, on it, pending, accepted. Okay, so that is the thing. So brute force, right? Brute force solution, because the size of each word is small, 50, and the length of words is also small, 20. We check each word with the pattern, right? Letter by letter. We use a dict to serve as mapping between each letter in the pattern and the letter in the word. This mapping allows us to check for injection. Meanwhile, we also set up a set of lowercase English letters. Each time a letter from the word is mapped, we remove the letter from the set. This is to check for surjection. Once both check passes, for all the letters in word and pattern, we have a match. Any failed check results in a non-match. So this I will call it ONM, where N is the length of words and M the length of each word. And what do we get? Oh, way outside the range. I don't even know, man. I feel like they allowed this to pass. I was very lucky they allowed this to pass. Yeah, I'm at 64. And even that's very slow. 64 milliseconds. Too slow to even have a ranking. So about half as slow as the regular solution. So definitely there's a much better solution than this. Okay, let's try to think about if we can find this better solution. So apparently we cannot do it like, we cannot check like this, right? That's the thing. Or maybe there's a, let me think. A, B, B, and M, E, E. We want a 1 to 1. We want a 1 to 1. The order doesn't matter, right? The order doesn't matter because what we want is just a mapping from each letter in the pattern to each letter in the word. That's what we want. So what if we just do, a counter, right? So a counter for this will give us each individual letter with a number of counts in it. And this will give us each and a number of count to it as well, right? So we compare these two, right? We compare these two. Therefore, if the size are the same, if the size is not the same, then that means there cannot be mapping. So what we want is the size must be the same. So it will be the same number of elements in both, and then if the length, hold on, let's think if this is true. If two strings have the same length, right, and they have the same number of unique letters in it, can they be matched, right? Can they be matched? Can they be like a bijection match? So same letters, same number, so the length is the same, right? And then each individual, we have the same number of individuals, unique ones. Then I think they can. So what I'm trying to say is we might be able to do it. Let's load the default code. All right, so load the default code and try it again. So this one just way too slow. So I think what I'm thinking right now is do it this way. We need from collections import counter. Right, we need a counter. So basically, oh, we don't even need a counter. No. We're just gonna take a set. Right? So this is what we do. We say return W for W in words if len word is equal to len pattern and len set word. Now not word, I think I used W for this. Len set this equals to len set pattern. But actually we do this too many times, so we can simplify it. We can say LP, len pattern, and len set pattern equals len pattern and len set pattern, right? And then this is going to be LP, and this is going to be len set pattern. And we do 2. Fail. Of course it fails because the order does matter. The order does matter. So we need to do one more check. So we have 2 checks, right? The first check, second check. We just need to do the third check. Third check just means we need to make sure that the ones that we want is, I mean, we can just put these 2 checks first, right? And then if these pass, then we need to check the last. How do we check the last? Do we do a word by word check? I mean a letter by letter check? A letter by letter check. It's like we know they have different letters and they have the same number of letters. It's just we don't know if they're um, arranged in the same way. So I mean we can, right? Just do a check. So I can say a third check is going to be word by word mapping, map, and could be just a letter to letter check. Can we do it easier? Right? Is there an easier way? I don't know, man. I think it has to be letter by letter check. Let's try it then. A letter by letter check. So map the first one, and we can map the second one, right? And then there has to be a function. This has to be a function. How do we do this function? How to call it? Say is match. Again, is match. Same thing. Word, letter, pattern. It's not boolean, but we change it. We're gonna say right, I'm gonna be here, and just say if len word is equal to len pattern and len set word equal to len set pattern, then we check and we say for WP in zip word and pattern, and of course we're going to have a mapping. If P not a mapping, then P then mapping P equals W. Aleph P mapping P is not equal to W, then return false, right? Then after we check, this is going to return true, and this is going to return false, right? We don't need this line, so this will still be the same. If self.isMatch a word and a pattern. IsMatch take 2, but 3 are given because I forgot to put self. Okay, let's try this one and see how fast this one goes. So we eliminate, I think we eliminated quite a lot of comparison already. Try it. Ending, judging, accept, and see how fast this one goes. No, I think this is still slow. It's still slow. I don't know. Are there any better ways? Like, I mean, it's slow because of this, right? Surely it's because of this. That's because we just check one by one. I mean, we already avoided the check. Yeah, this is still slow. This is still slow. Still slow. I mean, the runtime actually didn't improve actually. Didn't improve. Still OMM. Okay. Do we have another ingenuity pattern? Right. We're trying to say, like, if we can identify a pattern, what could be the way to identify the pattern? All right, let's take a look at the solution. All right, what genius way do we have? Okay, this is supposed to be a medium question. Yep. All right, let's see. Two maps. Okay, we can do two maps. Basically, this is two maps. Code. What's this number? 890. 890. Okay. Mapping. Two maps. Zip. Okay, that's the same, I think. W not in M1, yeah. P not in M2, yeah. If M1 not, I'm going to turn false, otherwise I turn true. Filter, huh? That's the same. It's the same as the one I use, but okay, granted, it looks simpler. One map. Okay, one map. And this is a one map. This is a one map. Forward mapping, okay, instead of keeping track of reverse map, you simply make sure that every value in a codomain is reached at most once. After defining same way, after we make sure it reaches distinct values. So xy in zip, p dot set default xy. Now you go to y and false. Len set equals set len p dot values. Okay. Is this one faster? It's the same. It's the same. That's the one mapping. And then this basically we just map it first. After mapping, we check p dot values, right? We want to make sure that there are not a case where the same letter in the word is matched to different pattern, to different p, right? So what we can do is for each p we can match to a word, right? But it could be that two different p match to the same word. So this is to check that, which is the same. I mean, I did it here, but maybe it's slow because I think this solution will pass if I have word and patterns different size. Honestly, let's try this. I think it will pass like console. Like this. I think this one will, I don't know. I think it will pass. Oh, hold on. What is this requirement? Oh, shoot. Didn't see that. Didn't see that line. Ay, ay, ay. Okay, so which means I don't have to do this anymore. All right, because it's already set. The length is equal to pattern.length. Aye, this is a mistake. Should have read it. And then I don't need this one either. Okay, I'm gonna submit 2 more solutions. I mean, the same one as before, but a little bit. So and let's not do all these. This is unnecessary. All right. So run code. Oh. Oh, I have the wrong thing here. Actually, we can run it here. Yep. Try it again. This one. See how fast. We remove the length check. There we go. There we go. There we go. That's why, because the length check is taking too much time. So this one gives us 24 milliseconds with a 97% ranking. I gotta read the question carefully, man. So how about this one? And this one should be about the same. Let's try this one. Yeah, this is about the same. I can call it 32 milliseconds. Okay, then it's the same, right? It's the same thing. I mean, which one do you like? We can do a set, and I do a set as well. But the thing is, I can make this one even faster, right? Even faster by passing in the length of the set. So LSP, right? And we can just say LSP here, and we could compute LSP equals len set pattern here, right? We compute it first and put LSP in, and then we only compute that once. Maybe that can even second speed it up a little bit more. Let's see. Yeah, okay. It's just we're micro optimizing, so it's not worth it. Yeah, it's not worth it. I like to have it one line. No, it's not worth it. Not worth it. All right, I think that's about it. I mean, there's not much to say. Set default for 2 maps. m1.setDefault, m2.setDefault equals ij zip. Okay, I zip it. I have j's pattern, I is that, and we m1.setDefault, I is going to be j, m2 set default, so j has a map to I, and this one. Okay, what does set default do? Python set default. Why the documentation is always not in the first one? All right, W3 school set default. Get the value of the model item. Return the value of the item with a specified key. If the key does not exist, insert the key with a specified value. Oh, okay. Okay, I know. So basically just say if it doesn't exist, we're gonna set it. So I gonna be mapped to j gonna be mapped to I, and then If it does exist, then it's just going to take out the I. If it's not J, it's something else. That's about right. Readability. No, this is good. This is good. Can I upvote this one? Oh, 998. He's gonna hit 1 million star very soon. Let's be part of the reason why he will hit 1 million star. Oh, almost there. 99992. Pass the f pattern to the sub function and return earlier in case of this match. C in W, set default C, len M. What is this? Hold on. This is different. So for each word, right, for each letter, I set that to the length, current length of M. And wait, what is this? Current length. So what we're mapping is at this word, this is gonna return a number, right? A length. So at this, the length, the first appearance, where does no. Yes. This is the like each where. Hold on. What does this one return? That means if I have a pattern, right, and then the first one, and then can be 0, and the second one can be 1, and if I have a repeat, and it will also be the first one. Oh, this is the pattern. This is the one you're looking for. Oh my god. Oh wow. My lord. Wow. All right, did you hit 1 million? Aye. 99993. Well, this is that's define the pattern. That's define the pattern. Ah, I see. Because I was thinking like, how can we use the actual pattern, not do a zip, right? Not do a letter by letter match. And you can by using. So what it's saying is we are recording the occurrence. We're recording the first occurrence, the index of the first occurrence of each unique letter in the word or in the pattern, right? And we replace the actual letter with the number, with the index, right? And then when we come out with an index, then the pattern is revealed. So the letter is removed and replaced by indices of the indices of the letter's first occurrence, and then the two can be compared. Wow! Holy moly! This is good. This is very good. All right, I'm gonna write this. And it's fine. It's very straightforward. So I don't think it matters too much if we even have this open. Wow, this is the smart solution. All right, it's good, very good. Nothing else to say. Nothing else to say. Oh wait, not this. Nothing else to say. Yeah, I was thinking. I was thinking if it's possible. Apparently, it is possible. So the true pattern, right? So this is a solution by Lee, 215. He is able to acquire the true pattern from pattern using the indices of the first occurrence, right? The first occurrence of each letter in the pattern. I'm gonna do the reference here. Okay. Come on, somebody like his comment that can reach 1 million. I mean, I see it tomorrow is gonna be 1 million. I was not the one to get to 1 million. Anyway, so def get pattern, get true pattern. Alright? So we're gonna have get pattern, not true pattern, just get pattern. Get pattern word, right? Word gonna be str, we're gonna return a list of int, right? So we're gonna say for word in word, for letters, like for word in word, right? What we want is, yeah, I have his method in mind. Like I can't get it out, so we can call it a mapping, right? And then what we say when we return this, right? What we want is mapping dot set default, which means if W has not occurred, it's going to set to len mapping. The first occurrence. It's actually not the first, not the index, not the indices. It's just using the order, right, of the first occurrence of each letter. Right, it's the order. It's like the first time occur, second time this one occur. The order of the order. How do I say this? I don't know. But we see the code, we know, right? So we'll set default in W, we're gonna map into 0 or to 1, and then that's it, right? And then we say pp equals get pattern, right? W for W in words if get pattern word equals pp. Word is not defined because I did not use word, I used W. Nice, nice. Trailing white space. Okay, so we're gonna try this one. Doesn't matter about the runtime, but it's just nice, very nice. Submit. Nice. Good solution. Good solution. All right, that's it. 3 solutions, and I hope I can remember this. The pattern defined till. Oh, that's what he says. It's to normalize the string, right? It's to normalize the string. All right, that'll be it. That'll be it for today. Good question. I will see you guys tomorrow. Adios.